Hello and welcome in a new video. My name is Wahid Anwar, and today we will be exploring the important field of risk analysis. Managing a project is much like navigating a journey. There are opportunities ahead, but also potential obstacles along the way. So, risk analysis helps us to identify those uncertainties in advance and prepare strategies to deal with them effectively. So, in this video, we will be exploring a variety of techniques used in risk analysis, into four main categories: qualitative, quantitative, hazards, and reliability risk analysis, and scenario techniques as well. So, by the end of this session, you will not only understand how these techniques work, but also know how to apply them to strengthen the decision making and improve project outcomes. Okay, so let's start. Let's talk about qualitative technique, or you can say qualitative risk analysis. So you can read here a method to prioritize risk based on their probability of occurring and their impact on project objective. Okay. So, actually, these are the methods that help us to analyze risk without needing a ton of, uh, the numerical data. So, they are more about judgment, experience, and classifying risk. Okay, so first we have your risk probability and impact matrix. I have added an example here in a picture. You can check it and you can also understand. So actually this is the first tool, the risk probability and impact matrix. So it's a classic for a reason. Imagine you can see a simple two-axis chart. On one axis we have the probability of a risk happening, and on the other we have its impact if it does happen. So we use a simple scale, say from 1 to 5 for both, and we then plot each risk on this matrix. That fall into the high probability and high impact quadrant. So what we call the red zone are the ones we need to act on immediately, and they are the most dangerous. Okay, here you can see high here. Okay, so let's take an overview of the definition. A qualitative tool that evaluates risk based on their probability of occurrence and potential impact on the project objectives. Okay. Next, we have how it works. Define probability and impact scale. For example, 1 to 5. Plot risk on the two-dimensional matrix, low to high. Categorize risk, for example, low, medium, high. Okay, so risk with the high probability and high impact falls in the red zone, requiring urgent action. So I have also added the reference from the different books so you can check. Okay, so I hope risk probability and impact metric is clear. Okay, so next up is risk urgency assessment. So, actually, this technique is all about timing. It helps us to figure out not just if a risk is a big deal, but how soon we need to respond to it. Okay, so we look for warning signs or symptoms and assign an urgency level like the immediate, short term, or long term. So, for example, if a key vendor contract is expiring in 2 weeks, so that's an urgent risk. So we don't have time to waste. Okay, so here you can see I have mentioned here example. Okay, so let's take overview of the definition of a risk urgency assessment, a qualitative technique that assesses how soon a risk may occur and how quickly response is required. Okay, so how it works: review warning signs, symptoms, and time frames for each risk. assign urgency levels, immediate, short term, and long term. Okay. Then okay, so after that we have Pareto analysis. Pareto analysis is also known as the 80 by 20 rules. Okay, so it's very common 80 by 20 rule. So actually, this is a powerful concept you can use in many areas of life, not just risk. So the idea is that about 20% of the causes are responsible for 80% of the effects. So in risk analysis, this means a small number of risk or their causes are likely responsible for most of your project's problems. So we identify the risk, quantify their frequency or impact, and then focus our energy on addressing that critical 20% that's causing the most trouble. Okay, so next we have the definition. So under definition, you can read. This is the actually a technique that identifies the few causes that contribute to the most of risk or problem. So how it works. So list risk causes, identify their frequency, impact, and plot them in descending order. Focus on the top contributors. Okay, so example we have here: 20% of causes create 80% of project delays. Okay, so I hope this is clear. So now let's discuss about the quantitative risk analysis. Uh, so you can read here numerical analysis of risk to understand their possible effect on project objectives such as cost, schedule, or scope. So actually, this method. Often we use when you have data and want to put a number on things. So uh, this method actually gives us a more precise objective view of the risk. Okay, so under quantitative risk analysis, first we have Monte Carlo simulation. The Monte Carlo simulation is a fantastic tool that uses the power of computing to simulate thousands of the possible product outcomes. So it likes actually uh, it look like this the picture I have added here. Okay, so it takes your risk variables, so like time and cost, and runs countless scenarios using random variables based on probability distribution. So the result, it gives you a clear picture of the likelihood of different outcomes, like saying there is a 70% chance of our product will be finished within 12 months. So it's like a crystal ball, but based on math. Okay, so Monte Carlo will be look like this picture I have added here. Okay, so let's see what we have under definition. So definition, you can see a quantitative tool that simulates product outcomes by running thousands of scenarios using random variables. Okay, so how it works: define a risk variables, time, cost, etc. Use probability distributions, run simulations to calculate likelihood of the different outcomes. Okay, so here we have the example. Product has 70% chance of finishing within 12 months. Okay. So next we have decision tree analysis. So decision tree analysis is a great visual tool for making tough choices. Okay, so it's a diagram that maps out different decision options. So it helps you to see the potential outcomes of each choice. So it include the risk and their probabilities. So by calculating the expected value of each path, you can compare options like choosing between vendor A vendor B for the low cost, high cost, low risk, high risk, and then make the most informed decisions. Okay, so here we have the definition. It's a diametric technique that evaluates different decision options considering risk, probability, and payoffs. Okay, so how it works? So map out decision nodes, chance nodes, and outcomes. Calculate expected value for each path. Okay, we have example here: invest in vendor A, high cost, low cost, versus vendor B, low cost, high risk. Okay, so I hope this is clear. So next we have here the sensitivity analysis, that also called tornado diagram or tornado analysis. Actually, you can say the tornado diagram or sensitivity analysis is the techniques which uh, which help us to figure out which variable have the biggest impact on our project's outcome. Okay, so we change one variable at a time, say resources availability, and see how much the project's schedule or cost can change it. So the variable that cause the biggest swings are the ones you need to pay the most attention to. Okay, so the resulting chart looks like a tornado with the most sensitive variables at the top. So here we have the example here: positive impact, negative impact. Okay, so let's see what we have under definition for tornado diagram. So a technique to determine which variables have the greatest impact on project outcomes. So how it works? So vary one input variable at a time while keeping others constant. So measure changes in project results. So schedule. Next, we have the example. Schedule is most sensitive to resource availability. Okay. So I hope this is clear. Okay. Then next we have here the expected monetary value (EMV) analysis. Okay. So actually, the EMV analysis is a statistical tool that calculates the average outcome when risks are involved. So this is the formula. How it works, you can see EMV equal to probability multiplied by impact. So we used in decision tree analysis. You can see here. So next, first let's take the overview of the definition. A statistical technique that calculates the average outcome when future scenarios include risk or opportunities. Okay, so how it works? We have already read this formula. Then next we have the example: 30% chance of 100k dollars loss, so equal to EMV of minus $30,000. Okay, so actually, if there is you can say there is 30% chances of 100,000 loss, the EMV is minus 30,000. So this number helps to understand the financial impact of the risk in the long term. Okay, so after that we have a default tree analysis, FTA. Actually, you may recall seeing a few of these techniques such as event tree analysis, fault tree analysis, and FMEA during our discussion on risk identifications. So that's because they are so versatile while we use them before to help us find potential risk, we also bringing them back today because they are also powerful tools for analyzing those risks in details. Okay, so fault tree analysis is a top-down deductive approach. We start with the major failure event like server downtime and work backward to find all the possible causes. So we use logic gates like and or. Okay, so so actually, we use this, the logic and or to map out the chain of events. For example, we have here, for example, server downtime caused by power failure and backup generator failure. Okay, so let's see the definition. What we have under definition: a top-down detective method to analyze causes of the system failure. Okay, so how it works: start with the undesired event, break it into causes using the logic gates and oblique or. Okay, so I hope this is clear. So after that, we have here the event tree analysis. So event tree analysis is the opposite of FTA, the fault tree analysis. So it's a forward bottom up approach while using this event tree analysis. We start with the triggering event like fire alarm going off. Okay, and then map out all the possible outcomes. So we follow the success and failure path, assigning probability to each one. So this helps us to see all the different potential consequences of an event from a successful excavation to major loss. Okay, so here we have the definition of forward bottom up analysis starting from an initiating event to examine possible outcomes. So how it works, start with the triggering event, branch into success, oblique failure path, assi- assign probabilities. So example we have here, alarm, fire alarm works, evacuation success, alarm fail. Next we have hazard and reliability risk analysis. These the techniques are often used in safety and engineering fields to analyze hazards and system reliability. Okay. Here we have the definition: hazard and reliability risk analysis is the process of identifying potential hazards and evaluating system reliability to understand the likelihood and impact of failures. Okay, so first we have here failure mode and effects analysis. So FMEA. So FMEA is a systematic way to identify every potential failure in a system and understand its effects. So for each potential failure, we rate its the severity, occurrence, and the detection. So we then calculate our risk priority number. Uh, the higher the risk priority number means the higher the priority for action. So for instance, in the engine overheating would likely have a high risk priority number because it's both severe and likely to occur. Okay, so here you can see under the definition the systematic technique to identify the potential failure mode, their effects and priority, then how it works. So rate each failure node by severity, occurrence, and detection. Calculate RPN or risk priority number. Okay, so I hope this is clear. So after that, we have here failure mode effects and criticality analysis (FMECA). So FMECA is an extension of FMEA. It adds criticality analysis. Not all the failures are created equal, and engine, the failure on a plan is far more critical than a broken cable light. Okay, so FME CA helps to prioritize failure based on their probability, severity, and their mission critical importance. Okay, so under you can see here what the definition and extension of the FMEA that includes the criticality analysis. Okay, so how it works: prioritize the failures by combining probability, severity, and mission criticality. Okay, so I hope this is clear. So next we have the example I have just explained here. Okay, navigation engine failure critical, while cabin light failure is slow. Okay, so next we have the hazard and operability study. Okay, so actually, this is a structured technique used to identify hazards in processes. So you use a set of the guide words like more, less, or reverse to systematically explore potential deviations from the design. So, for example, in a chemical plant, our team might ask, "What if there is more pressure than designed?" So, this helps them to proactively identify a risk like an explosion. Okay, so let's see what we have under definition. Definition, you can see a structure technique to identify hazards in process, design, or operation. Then how it works: use guide words more, less, reverse to test the deviation from design intent. Okay, so example in chemical plant, more pressure means the explosion risk. Okay. Okay, so after we have here bow tie analysis. Actually, this is a simple but powerful visual tool. It looks like a bow tie. The central knot you can see here. Here we have here the hazard. Okay, you can see here the central event hazard. Okay, uh, that central node is the main risk event, like an oil spill. The left side of the bow tie shows all the causes and the preventive controls you have in place to stop the events from happening. So on the right side show all the potential consequences and the recovery measures you will take if the event does occur. So it gives a complete picture of your risk and control strategy. Okay, so you can take overview of this picture. Okay, so in the middle we have the knot. Here we will have the main risk event. Okay, so under definition, you can see a visual method linking causes of the risk left side and consequences right side through the risk event center. Okay, so how it works: show the preventive controls left and recovery controls on the right. So, oh, okay. So here you can see I have just cleared before this example while spill equal to preventive barriers, walls, and recovery measures, cleanup. Okay, so next we have human reliability analysis. So actually, this technique focuses specifically on the risk of human error. It helps us to identify tasks where human error is a factor or estimate the probability of that error occurring. Okay, so here you can see the definition: a technique to evaluate the probability of human error affecting this system safety. Then how it works: identify tasks, potential errors, estimate error probability. Okay, so the example of operator misreads control panel 1 in 100 chance. Okay, so we might estimate the chance of an operator misreading a control panel. You can read from 1 in 100. So this is crucial for projects where human actions are critical to safety, like in aviation or nuclear power. Okay. So next we have scenario techniques. Scenario techniques are risk analysis methods that explores different possible future situations to understand the uncertainty and their potential impact on project objectives. Okay. So under scenario, first we have this same name, scenario analysis. This is the technique actually. So, scenario analysis is about imagining different possible futures of your project. So, you can develop a best case, a worst case, and a most likely scenario. Okay. Then you evaluate how your project would perform in each one. So, this helps you to prepare for a range of outcomes. Okay. So here we have the definition. Explores possible future scenarios and evaluates project performance under each. Then how it works: develop the best case, worst case, and most likely scenario. Assess risk impacting each. Okay, so here we have the example: oil prices, a surge scenario increase project cost by 30%. Uh, so it's mean the oil prices increasing your product cost by 30%. Okay. So after that we have the pre-mortem analysis. So this is a unique and effective techniques. So this in this technique the product team imagines that the product has already failed. So then they brainstorm all the reasons why it failed. So it's like looking back from the future to identify potential pitfalls you might have missed. Okay, so this helps you to identify and plan for the preventive actions. Okay, so here we have the example. A definition, a forward-looking technique where team imagine the product has failed and identifies possible causes. So how it works: brainstorm failure causes, rank them, and plan preventive actions. Okay, product failed because supply defaulted. Okay, so this was the example. So next we have the frameworks and standards. Okay, so framework and standards are the structured guidelines and best practices that provide a common approach for managing project risk or processes consistently and effectively. Okay, so frameworks and standards are structured guidelines that help us to manage project risk and process in the consistent and effective way. So this provide a common approach. You can say everyone can follow, making sure work is aligned, organized, and meets the professional best practices. So, by using frameworks and standards, teams can reduce confusion, improve efficiency, and ensure projects are delivered with quality and reliability. Okay, so first we have ISO 31000, then ISO 31010 framework. So actually this is we have the international standard for risk management, ISO 31000. This is you can say your go-to guide for the principle and guidelines for risk management. It's not set of rigid rule, but a framework you can adopt to any organization. It provides a structured methodology for everything from defining risk to treating it. So, so its companion ISO 31010 is a specific guide on a risk assessment technique. So we have actually discussed many of the techniques from this standards today, like Monte Carlo simulation and FMEA, etc. Okay, so uh, here we have the definition: ISO International Standards for Risk Management Principles and Assessment Techniques. So you can see use provides the structured methodology, guidance on selecting techniques. Okay, so reference is also given here. After that, we have here the PMBOK risk management process. So here I have added the example from PMI. You can see PMBOK, a product risk management overview, step one, step two, step three, step four. You can read here, then step five, six, seven as well. Okay, so we have the PMBOK guide from the Product Management Institution. I mean PMI. So this is the risk management process in PMBOK. So the PMBOK framework, the breaks risk management down into a series of logical steps like the identifying, analyzing, or analyze, plan, implement, and monitor. And then you will find that all the techniques we have discussed today fit neatly into the framework. So, for example, our discussion on a qualitative and quantitative analysis fits perfectly into analyze step, and our talk about the risk response fits into plan. Okay, so here you can see the definition PMI's framework for risk management in products. Okay, so includes identifying, analyze, plan, implement, monitor. So next we have Prince 2 risk management approach. So the Prince 2 methodology also has a strong focus on risk. So it requires the creation of a risk register where all identified risks are recorded and tracked. Then it also defines the specific roles and responsibilities for risk management. Okay. For example, the risk manager is responsible for managing day-to-day risk, while the project board handles the strategic risk. So this is a very structured approach that ensures risk is integrated into every stage of the project. Okay, so under definition, structured project management methodology with the integrated risk approach. So use risk register, roles and responsibilities defined. Okay. So next we have COSO ERM, Enterprise Risk Management. So actually this is also you can say a framework. So this is for the enterprise wide risk management. It's much broader in scope then looking at how risk affect the entire organization, not just one project. Okay, so it helps companies align their strategies with their risk appetite and make sure that risk management is a core part of their governance and internal control. So this is the framework you use when you want to look at the big picture. Okay. So here we have the definition. You can see here COSO framework focusing on governance, internal control, and risk. Then use a strategic and enterprise-wide risk assessment. Okay. So next we have the octave method that This stand for uh, operationally critical threat asset and vulnerability evaluation. Okay, so this is you can say this one is the specifically for the cybersecurity risk assessment. It's an excellent example of a risk framework tailored to a particular domain. So it guides you through identifying critical assets, understanding threats to those assets, and evaluating the vulnerabilities. Okay, so for anyone working in IT or cybersecurity, this is an essential tool for protecting your digital assets. Okay, so in the definition you can read here the cybersecurity risk assessment methodology. The use identifies critical assets, then threats, and then vulnerable abilities. Okay, so these were the risk analyze, you can say risk analyze techniques. So I hope everything is clear. So thank you so much for watching this video. See you in the next video.